Hi, welcome to Layman's Guide to Cracking the Coding Interview. So today we're gonna be solving some of the problem that we solved earlier, but slightly changing the questions. So let's see. So given an rotated sorted array, find the minimum value in the array. So for example, this would be the sorted array, right? Like we have a 0, 1 up to 9. So if we rotate by few angles or like rotated by some clockwise or anti-clockwise, then our given array would be 2, 3, 4, 5 up to 9, and then from this index we have a 0 and 9 because the 0 goes at the bottom and the 1 goes after the second rotations. So this is like a rotated version of the sorted array. However, it's sorted but slightly changed at some index. So that's why we need to find the minimum from this given array. So let's say we have the input 8, 9 and 0, 1, 2 up to 7. So in this case, the minimum would be 0. Or if we have this as a given input, then in this case, the written value should be 3 because that's the smallest. And in this case, we could have the repeated, we could have the 0, we could have the negative or any kind of integers. So that's the input, and let's see how we could do this. So for the sake of simplicity, I put the height of a people at 0, 1, 2, 3, and 4. Literally, there wouldn't be a height of 0, but just for the sake of simplicity, let's assume it's almost limit to 0 or like a 0 point something. So in an integer, I put it 0. So in this case, we have a 5 people and with the height of 0 and up to 4. So, and it's in the increasing order. So we should say it's in the sorted form. So we need to find the minimum. The minimum here would be the 0, the one which is at the beginning. So, but now we need to rotate by a few angles. So now the one who was the taller comes at the first, and the rest remains the same. And again, the who was at the bottom again comes at the front. So in this case, it's rotated by 2 degrees or by 2 clockwise. So we have a 3 and 4, and then 0, 1, 2. So in this case, we need to find whether this one is the smallest or no. So I mean this is the smallest, so we need to find the value of the smallest height. So how we do? So it's gonna be similar to the binary search, except we need to check for one condition. So similar to binary search, we have a left and the right. The left would be the index 0 and the right would be the last index. So this is the left, this is the right. And now we need to have a mid. In fact, there should be a condition, but just for the sake of like sequential, I didn't put the while statement in the program. I have put that. We can check that one later. So here in this case, this would be the mid. So when we find the mid, so the condition we need to check is if the height, these are the height, or these are, or we could say it as an array. So mid array, if the mid array is smaller than the previous one, so this one is the mid one. So if this is the smaller than the previous one, then this is the smallest one, right? So for example, if this was the mid, we check whether the earlier one is smaller or no. If not, then this is not the smallest. So here in this case, this is the mid, and whoever in front of the mid, if it's a taller, then the mid is the smallest. So that's what we do. So if the height of the mid is smaller than the height of the one who is in front of you, then you are the smallest. So it's gonna return the height of the mid index. So we have that case. So there may be other cases as well. This smaller could be before the mid, or the smallest could be after the mid as well. So we need to check that condition. So now we have this many people, and we have from 0 up to 9. So we have 10 people here standing, and we need to find the smallest. So just for the sake of simplicity, I will just clarify that if this is the mid, the smaller could be either in front of earlier sections, earlier half of the mid, or the later half of the mid, right? Either on the first half or the second half of the mid. So in this case, it's on the first half, or it could be even on the second half. So we need to check that condition. So every time we could assume like if this is the mid, then we need to check whether the left index or the first index is taller than the mid, and if the last index is also the taller than the mid. So in that situation, the smaller would always be on the first half in that situation. So here we apply that condition. So here we're gonna be checking if the height of this mid is smaller or equal to the mid. Sorry, we're checking this one in fact. So this condition is not valid for this height for this given input. This should return false. So we have another condition for this constraint. So let's just check this constraint. So here we have a if else. So in a if else, we are checking if this guy, the one at the leftmost, is smaller than the mid one or equal to mid one, because we need to put this equal to, might be the one that has the similar height as well. So just for that, I'm putting the less or equal to, and we're checking with the mid one, right? So if the leftmost is smaller than the mid one, and there's another condition, and this mid is taller than the right one, in that case we need to shift the left index after that. But in this case, this is not the true case for this here, because the mid one is smaller than the left one, and we don't even need to check this one because this is the end. Just in case if we need to check if the mid is taller than the right one, which is also not the case, because mid is smaller than the right and mid is smaller than the left. So we don't have to change the left index. In that case, we need to check. If this was the valid case, then we need to change the left index. So, but this is not the valid case. So we go on to the else statement. Else, we just need to change the right index would be the mid minus one. So this was the mid, so the right index would be right over here. So then after that, we will just be evaluating this section, like from 8, 9, 0, and 1. So in the same case, we will apply the same iterations. I don't have the while here, but I have it in a program. I can show you later. So these are the only constraint we need to check. So, see, we could just see it from the height. This one is a taller, like a mid. This one is the tallest, and this one is on the left, and this one is on the right. So the mid is not the taller than left and the right. So we don't change the index of the left. We just change the index of the right. So because we need to only take care of this half, this section. So we'll do that in a program. So, and the runtime of this program would simply be the log of n, because it's just doing a binary search. We're completely ignoring the other half, and we're just taking care of the next half. And even in this case, the next half would be the same. So this would be the left, this would be the right, the mid would be this. And when mid is this, we check whether the mid is taller than the left, yes, and we also check whether the mid is taller than the right, yes. So in this case, would follow this like a statement. So that we change the value of the left. So the left would be over here. So left and the right. So there are only two. So in this two case, we take the mid would be itself over here. So when the mid is over here, there's no, we can just simply check with the in front of this case. So this in front of this mid is taller, so this mid itself is the smallest one, so we return that value. So in the last iteration, this would be the valid one. Let me run the program so we could see it more clearly. So okay, we have this given statement right over here. I just copied here, and we have an input as from 8, 9 and 0 up to 7. So this is the rotated version of the integer array, and I'm just gonna run the program. So here the 0 is the smallest one, so it returns the 0. So let me put the debug. I can put it from here so that we could see. Close this. So we're checking the base case. If the given input or the given array is just empty, then there's nothing to return, so we return -1. If it's just a 1, the length is just a 1, then we don't need to compare with anyone. So that could be the smallest one, or that could be the biggest one. So since we need to find the minimum, so we just return that value, and then we put the left and the right as usual. Okay, now we have a while statement that checks whether the left is smaller is always smaller than the right. I think I should put less or equal to. Let me redo. Okay, so now we find the midpoint, and we have a midpoint as 4, and then we check whether the 0, 1, 2, 3, 4. So whether the 2 is the smallest, right? So we check if 3 is the smallest. It is not, because anything in front of the 2 is still the smaller. It has to be the bigger, so that's not the case. And then we check this statement as I discussed earlier. If 2 is the bigger than 8, and if the 2 is bigger than the 7, which is also not the true, so then we go on to the other case. So we change the value of the right, so the right would be this one now. So now the right is 0, and the left is 0, 0, 0 up to 1. We need to just take care of the range from 0 to 3, and the mid will be changed. So now the mid is 1, so mid is at the 9, and we go through the same cases. Is is the 8 bigger than the 9? No. So the first statement is not true. Then now we have like we check this one, whether the 9 is bigger than the 8, yes, and whether the 9 is bigger than the 1, yes, it is. So now this case is validated, and then we need to change the value of the left. So now the left value is changed, so now this is going to be the left. So we have a range from 2 to 3 only, so 0, 1, 2 and 3. So 2 and 3 is 0 and 1 value. Index 2 and 3 is 0 and 1. So now we get the midpoint. So the midpoint is itself a 2. So now we have a 2 as a midpoint. So now we compare whether the value in front of the mid is bigger, and in this case it is true, because 9 is bigger than 0, and then we simply return the smallest one, the midpoint, and the mid is the smallest. That's it. And then we have the result as a 0, and it returns that one. And let me try with the other case as well. This one, let's ignore that. Let me put something else. I can comment this. So let me put some negative 12, 13, 14, 15, and then let me just do this 1, 2, 3, 4, 5, and then I can put it minus 6, minus 5, minus 4. So okay, in this case the smallest would be the minus 6, right? So so we have the minus 6 as the smallest that we could do, and even if you put the 0, it's going to be the same. No, we don't have to take care of that. With something, okay, because this is not in the sorted form. It shouldn't be like that, because it should be a sorted, just rotated, because the earlier one wasn't the sorted at all. So here we have the minus 6 as the smallest. So I'll just put it back to the same case, because even the input has to be in the proper format, because our algorithm just deals with the smallest value when it is a sorted, rotated, but the sorted one. So yeah, that's it. And the running time is just log of n. Thank you.